Hey guys, Mr. Larson here. Just wanted to walk you through an intro to some key features of graphs. The next couple class periods, we're going to talk about key features, and it can get a little confusing, but I think that a lot of the stuff we already know, whether from past math classes or from earlier this school year. So, what I'd like you guys to do is, if you look, we have A, B, C, D, E, F, so 6 different what we're calling key features of the graph that you see here on number 1. And then there's the same situation for a different graph on number 2. So these are 6 key features that we've talked about, and I want you guys to pause, see what you can do from 1 and 2. So here's 1, so you can pause that. And then here's 2, you can pause that. And what I will do is go through and just kind of explain these real quick, and then you'll see these, more and more as we go through the next couple weeks here. Okay. Okay. So again, you shouldn't be watching this part until you have tried number 1. So, X-intercept. We know X-intercepts, right? It's where we hit the X-axis. And we have to do a little bit of thinking on this one. If this is -2, that took 4 boxes, right? So this one must be -1. That looks like -1.5, right? 1.5. So X-intercept, make sure that you are listing coordinates, right? It's always your X-intercept, comma 0. Don't just tell me -1.5. I take points off for that. I'm sure your other teachers will as well, okay? So this would not be correct. -1.5. That's just a value, right? That's not an ordered pair or location on a graph. Okay, the Y-intercept. That's where it's the Y-axis, right? So this looks like -3 down here. So again, this seems to be the one where students always just want to write the value. I think because y equals mx plus b, we always say the y-intercept is that b value, which is just a number, but make sure you're doing 0, -3. Okay. Domain and range. So these always tend to be the trickiest one. And one clarification I want to make, I made these graphs on Desmos. Let's assume that there are arrows here on both ends, indicating that this graph is going to go forever in that direction, right? I just ran out of graph space. It wouldn't make sense to make a bigger graph because I'd have to do an infinitely big graph, which isn't going to work. So we kind of do like a shorthand of that, or these arrows are meaning that we're stretching forever in both directions, okay? So for your domain, the expectation that we're going to have from a notation standpoint, your teacher may differ, but I think what we'll have the expectation is if we look at this graph, this is an uninterrupted curve, right? This red line that's drawn, we call that our curve. I know it's not curved, it's not curvy, it's straight, but anytime you graph something, whatever you're drawing is called your curve, okay? So here's my curve, and there's no interruptions in this, right? So we're calling this continuous. You don't need to know this right now. You'll learn this later in the week. But anytime you have a continuous curve like this, where it's like a continuous line, it's not anything that looks like this, so there's no holes in the graph. What you want your domain and range to look like is, remember, domain and range measures left and right. So put your smallest number and then your biggest number, right? So smallest and biggest that you're allowed to be. And this is for my x values, right? Domain is x. So if I trace this curve, x gets really small to the left, so I'm going left this way. That's going to go forever, and it is going up, but it's also moving to the left. So it's never going to stop. It's going to go all the way to the left, and the smallest number we can have is -infinity, okay? The biggest number is going to be all the way to the right. So if I trace this curve all the way to the right, yes, it's going down, but it's also moving to the right forever and ever. Eventually, it's going to reach positive infinity. Okay, so we put the smallest number on the left, biggest number on the right. Since we're talking about domain, we put x in the middle, and then we always use less than signs. Okay, so Smallest on the left, the biggest on the right, and then either your x or your y, depending if you're talking about domain or range, in the middle. Okay, so how we would read this is negative infinity is less than x, which is less than infinity. All right, for my range, so this is my y value, and now we're talking up and down, right? Up and down. So again, I want to have my smallest number here, my biggest number here, okay? And we're going to put y in the middle on this one because it's our range. So the smallest number, y value gets really small as I move down. So the smallest number down here, if I were to keep going, would be negative infinity, right? It's going to go forever. Biggest number, if I go up, my biggest y value is going to be positive infinity. And we're going to put y in the middle because we're talking about range. And again, we always use less than sign for this notation. So we would read that as negative infinity is less than y, which is less than infinity. So basically what we're saying is this contains every number that there is, right? So another way to word this would be all real numbers. That would work for both of those. It's not incorrect, but it's not the notation that we want. Okay, notation is like how you write things. So we really want you to get used to this notation for, again, what we're calling these continuous graphs. Okay. All right. So for the next one, increasing or decreasing, we want to read this curve, read this graph from left to right, like we would read a book. And basically, are you going uphill or downhill? So as I go from left to right, ignore this arrow. That does not mean we are traveling in that direction. That just means the line is extending, okay? So from left to right, clearly I'm going downhill. This is a decreasing graph, okay? Circle one, this curve is positive, negative, or both. Well, I have positive or negative. We're talking about our y values here. Okay, so we're talking about y values, the outputs. Am I above or below the x-axis here? Okay, so this area up here is positive. Okay, so if I didn't have the part below the x-axis, I could say it's a positive graph, right? However, this part down here is negative. So I don't want to circle positive or negative. I actually want to circle both. This has one part that is positive, one part that's negative. Okay, so we would say both on that. Okay. All right, so number two, you should not be watching this part until you have tried to do all of these, okay, for number two. All right, so again, x-intercept, that looks like it's at an x value of -1. So it's a -1, 0. Y-intercept at 0, +1. Again, Desmos cut these off, but those should be extending in both directions. So the domain is our x values. So on this curve, my smallest, this is continuous again, right? It's just one. I don't have to pick my pencil up at all. I can keep drawing this, right? So if I move all the way to the left, which is where my smallest x values are going to be, that's going to go to negative infinity. That's my smallest. If I say it's less than x, which is less than, and then as I travel all the way to the right, I see that I'm going to keep going to positive infinity. And a lot of people think, oh, that's going up. That's not going to the right. Well, notice that as I'm traveling, I'm going a little bit more and a little bit more and a little bit more to the right. So it is continuing to go to the right, and then I'll go to positive infinity. Okay. The range. So up and down. My smallest y value as I travel down the graph. Well, this isn't going straight down, is it? This looks like it's kind of flattening out. And it is flattening out. And let's see, this is a little tricky, but it looks like every 2 boxes is like, that's a 2, that's 1, there's 0, so this would be -1. It looks like it's not passing -1, right? We can see there's kind of this imaginary boundary here. You're going to learn about that. That's called an asymptote. But what it really means in this context, or in this scenario, is that I'm getting closer and closer to -1, but that is my smallest y value. -1 is my smallest y value. There's kind of like a floor on this. Okay, so -1 is less than y, which is less than, and then my biggest y value, I move up the graph, that's going to go up to positive infinity. Okay. Okay. Let's circle 1. This curve is increasing, decreasing, or both. Again, we are going to read from left to right, just like you would read a book. So as I travel from left to right, am I going uphill or downhill? I'm going uphill. So that's an increasing graph. Right? This curve is, this is for part F now, this curve is positive, negative, or both. So again, we're talking about y values. Am I above the x-axis, below the x-axis, or both? And this one, again, we can see that I'm above the x-axis, positive y values here, and I'm below the x-axis here. So I can't call this a positive graph. I can't call it a negative graph. This one, again, is going to be both. It's got a piece that's positive and a piece that's negative. Okay. I hope that helps. Thanks for watching, guys. Appreciate it.